Why haven't we found alien life yet? Scientists have answers. One night about 70 years ago, physicist Enrico Fermi looked up at the sky and asked a simple question: where is everybody? He was talking about aliens. That's how the Fermi Paradox was born, brilliantly and simply. The next morning over coffee, Fermi discussed it with 3 fellow physicists. The universe is filled with stars. We constantly scan the night sky, and yet no signs of advanced civilizations. So could humanity really be the only technologically advanced civilization in the universe? Fermi asked. The first explanation was simple. Maybe Earth is unique. Maybe planets truly suitable for life don't exist anywhere else. Back then, we lacked powerful tools to observe exoplanets. But since then, new telescopes have appeared, and AI now processes enormous amounts of cosmic data. Today we know Earth-like planets aren't rare. Scientists believe our galaxy alone may hold millions, possibly billions, of planets where life could exist. So let's toss out the trivial ideas that extraterrestrial civilizations don't exist at all, or Earth is completely unique. First, those clash with probability theory. Life is likely common, Earth unlikely one of a kind. Second, trivial answers don't advance science. Progress needs imagination, exploring wild scenarios. That's how theoretical physics predicted particles and phenomena long before we saw them. The ancient Greeks worked this way too, describing reality so well their ideas lasted over 1,000 years. Let's examine the main hypotheses scientists proposed to solve the Fermi paradox. The zoo hypothesis. Konstantin Tsiolkovsky first suggested this in the 1930s. Why deny intelligent beings on other planets? They say if they existed, they'd have visited Earth. My answer, perhaps they have, but the time isn't right yet. American astronomer John Ball fully developed it in 1973. Extraterrestrial civilizations know about us, but choose not to reveal themselves. Their tech lets them stay completely hidden. They watch humanity without interfering, like us observing zoo animals. Contact happens only when we reach a certain development level. For now, we're just not ready. It's simple and intuitive, which explains its popularity. The zoo hypothesis shows up everywhere in movies and books, from humanity joining a galactic community to us secretly guiding other worlds' evolution. Hidden ocean worlds. Alien life may thrive in vast oceans beneath thick ice layers. Many planets and moons hold liquid water, not on the surface, but deep under frozen shells. We already know these subsurface oceans exist on solar system moons and likely throughout the galaxy. NASA's Alan Stern argues life could flourish in these water worlds, even if the surface looks hostile: toxic atmosphere, weak magnetic field, violent parent star. Yet beneath the ice or rock, conditions could be perfect. No matter how intelligent, such beings might never reach the surface or even know space exists. From a telescope, we'd never spot them. Trapped on super-Earths. Many exoplanets are super-Earths, more massive than Earth, far smaller than gas giants, usually 5 to 10 times our mass. Liquid water could exist there, but escaping would be extraordinarily difficult. A planet 10 times Earth's mass has escape velocity over twice as high. Launching a satellite? Nearly impossible. Inhabitants stay trapped by gravity forever. Not biological, but robotic. Human tech leaped forward fast. A century ago, radio. 50 years later, first computer in 1945. Today, we carry devices millions of times more powerful, powered by AI. Other civilizations likely followed suit, replacing biology with machines. No need for breathable air, water, or moderate temperatures. SETI's Seth Shostak suggests robotic civilizations migrate to energy-rich spots like galactic cores. Maybe we've already observed them without realizing it. We may not recognize them. People picture aliens as humanoids, but odds of extraterrestrial life resembling us? Vanishingly small. Evolution follows chance and local conditions. Expecting upright beings with arms, legs, heads everywhere makes no sense. Our imagination's boxed in by experience. Life elsewhere could be far stranger than we conceive. Civilizations that destroyed themselves. Alien societies may have wiped themselves out, climate collapse, nuclear war. Astrophysicist Adam Frank from Rochester modeled this. In 75% of scenarios, civilizations never reach spacefaring stage. Most collapse first, with huge population losses. Odds are high many destroy themselves before we could ever meet them. Natural civilizational decline. Even without catastrophe, civilizations may simply run out of time. Earth's been hospitable to life less than half its existence, volcanoes and ice ages before, solar expansion frying it in 500 million years. Life evolves slowly. Single-celled to multicellular took about 1.5 billion years. That leaves a narrow window, maybe a few hundred million years, for intelligence to arise and go interstellar. Humanity's window is limited too. We are drifting apart. The universe expands and accelerates. Dark energy pushes distant galaxies away, dimming their stars till unreachable. Without faster-than-light travel, violating known physics, civilizations stay invisible to each other. A powerful 1 billions of light years away? Contact chance, effectively zero. Same for cosmic objects generally. Fermi Labs' Dan Hooper puts it perfectly. Stars aren't just dimmer and harder to see over time, they'll become completely inaccessible. This sets a real deadline for finding extraterrestrial life. To outrun dark energy, our civilization would need to spread across galaxies before they drift away.